minutes left, so we have time for introducing the next speaker. It's Sara Antignani. Sorry. I'm a bit dyslexic, so there's too many consonants in this. She's going to talk about radon measurements and statistical methods used for predictions of indoor concentrations. We have 15 minutes, and whenever you're ready.
Good afternoon. Thank you. Thank you. Good afternoon, everybody. In this presentation, I talk about the comparison of statistical methods for high radon concentration applied to the same dataset. I'm giving this presentation on behalf of the subtask 2.4.1 group, and I reported here all the list of colleagues who contributed to this subtask. I'd like to thank them. And since it is the last meeting, I also would like to thank publicly and sincerely Laureline Ferrier for her constant presence in supporting the activity in Work Package 2 and promoting the activity, including this one. Thank you, Laureline. So back into the methods. We know that statistical methods are often used to predict radon concentration in buildings or to identify areas where high radon concentration are expected. And but generally, these methods are focused on average radon concentration. Meaning that in the end they predict factors affecting and influencing the average radon level. However, it has been shown that the influence of potential predictors can change as radon level varies. So a deeper understanding on methodological aspects of statistical methods predicting high radon concentrations supports the identification of areas and buildings with higher risk, contributing to a more accurate assessment of population exposure. Applying such methods is very useful to improve knowledge about predictors most likely connected to high concentrations. So such insights that this kind of methods could give us can support the prioritization of measurements and the implementation of mitigation strategies, and in the end the reduction of radon-related health risk. The first step, so we performed a literature review on to identify this method, and the results of the literature of this review are reported in this paper that was published last year. And what did we conclude from the analysis of literature? We understood that the first thing, that these types of methods are not so commonly used. In fact, we didn't find a huge number of papers applying methods specifically focusing on high radon concentrations. And although it's clear that the most effective way of comparing methods is by evaluating their performance on the same dataset. We instead found very few studies in literature that applied different methods on the same dataset. And so our goal, that was to compare these methods, turned out to be challenging. And because these different methods that we identified were applied to different data sets, and the analysis performed had a different data handling behind, and the models applied were different. And in addition, they used different performance metrics to evaluate the methods. So, we found indeed that the results of the applied methods are influenced by the intrinsic characteristics of the datasets, such as the type of data, the time when the data are collected, the location of the collection of data, and last but not least, the variable variables in datasets. And these motivated our subsequent work. In fact, we identified some suitable datasets that were available in our group, the partner who contributed to this subtask, and these are the datasets. So you can see that each dataset were very huge dataset in terms of dwellings involved, and two of them were based on were data coming from national radon surveys. And for each of these datasets, we applied different methods. The Estron datasets were analyzed by applying different machine learning techniques, namely random forest regression and random forest classification, and the quantile regression forest. The Swiss dataset was analyzed by applying two machine learning techniques, so random forest regression and classification, and logistic regression. The Italian dataset, we applied a XGBoost method, that is a machine learning technique, a logistic regression and a quantile regression, and the French dataset were analyzed by applying two different geostatistical approaches. While each analysis led to its own conclusions, sharing our thoughts, we were able to draw some common conclusion, hopefully some also general conclusion. And the first one is that these methods are more or less consistent, meaning that applying different methods to the same datasets, we consistently identified the most relevant predictors. And the key predictors for high radon concentrations were found to include building characteristics, so type of the building, age, the floor level, and the extent to which the base of the building is in contact with the ground. And also environmental variables such as geology or the soil characteristics, and this is in line with what is already existed in literature. Moreover, the Italian dataset made it possible also to investigate the impact of inhabitants characteristics on high radon concentration, and we found that to some extent also some variables have some importance. These variables are the presence of small children in the house, the year spent in the dwelling from the family, and the smoking behavior. And likely because these are variables and somehow connected with the rate of ventilation of the dwelling. The method performance, we found that method performance varies depending on how the target variable is defined. So if we use the radon concentration in its original scale, it's different. With respect, we log transformed radon to analyze it, or if we use radon concentration as a continuous variable, or if we categorize it and we use it as a categorical variable. And this consideration, particularly this consideration, highlighted the importance of aligning the workflows with the specific prediction goal. In addition, we know that radon distribution is generally considered and found to be log normal, and that the prediction of the right tail of the distribution is more difficult. And we found that predicting untransformed radon values or focusing on higher quantiles of distribution may improve the accuracy of the prediction of these high radon levels. As regards model performance, we found that the machine learning models show strong performance, good performance, with the R-square index that reach values up to 0.5. That is a very good performance compared with what is in literature. But we also found that sometimes the traditional statistical models, I mean linear regression, such like this, can obtain comparable results. In the end, applying several different methods to the same datasets provided in our analysis complementary insights, such as insights into the potential non-constant effects of a predictor as the radon level concentration varies, or insights on the potential interaction among predictors, or insights on the kind of relationship between a predictor and radon concentration, whether linear or not. So applying different methods could also be useful to confirm the selection, the identification of key predictors, as I said before. So in the end, based on this analysis, on this work, we can conclude that using the diverse approaches on the same dataset is not useful, but recommended to extract as much information as possible from the data that we have, because they can provide several different insights related to different aspects. So, if you are interested to have more details, you can take a look to the deliverable 2.9. Thank you for your attention.